Black holes are among the oddest phenomena. They seem incomprehensible. What causes them, and what happens if you fall into one? Stars, which are primarily hydrogen atoms, were formed from vast gas clouds due to gravity. In its core, nuclear fusion converts hydrogen to helium, producing significant energy. Radiant energy challenges gravity, balancing the two forces. Stars remain stable as long as there is fusion in their core. Stars of greater mass than our Sun can fuse heavier elements including iron due to heat and pressure in the core. Unlike previous elements, the fusion process for iron does not produce energy. Too much iron in the star's center disrupts the balance between radiation and gravity. Core collapses. In a split second, the star collapses, moving at a fourth the speed of light, adding mass to the core. When a star dies, a supernova explosion generates all heavier elements in the universe. A neutron star or black hole may result from the collapse of the core mass of a large star. When viewing a black hole, you'd observe the event horizon. Anything crossing the event horizon must travel faster than light to escape. In other words, impossible. The black sphere appears to reflect nothing. If the event horizon is black, what is the whole part of a black hole? The singularity. I'm not sure what it is. Singularities can be dense, concentrating all mass into a single point in space with no surface or volume, or something entirely different. We don't know yet. It's like a dividing by zero error. To clarify, black holes do not suck things up like a vacuum cleaner. Changing the Sun for a gigantic black hole would not significantly impact Earth except for the possibility of freezing to death. What if you fell into a black hole? Black holes alter the perception of time, causing it to slow down as you approach the event horizon. Eventually, you would appear to freeze, slowly turn crimson, and vanish. From your perspective, you may observe the cosmos moving forward, which is similar to seeing into the future. We don't know what will happen next, but we suspect one of two possibilities. First, you die quickly. A black hole bends space, resulting in a single direction once it crosses the event horizon. Within the event horizon, you can only move in one direction. It's like stepping into a narrow alley that shuts behind you. A black hole's concentrated mass causes millions of times higher stress on body components, even at small distances like a few centimeters. As your body extends, your cells tear apart, transforming into a one-atom-wide plasma stream. 2. You die too quickly. You would immediately encounter a firewall after crossing the event horizon. Neither alternative is appealing. Your death time depends on the black hole's mass. A smaller black hole would kill you before entering its event horizon, but a massive one could allow for prolonged transit. Generally, living longer is associated with being further from the singularity. Black holes vary in size. Black holes of stellar mass, many times the Sun's mass, and asteroid diameter exist. Additionally, super-large black holes, present at the center of every galaxy, have been feeding for billions of years. The largest known supermassive black hole is S50014+81, with 40 billion times the mass of our Sun. It has a diameter of 236.7 billion kilometers, 47 times the distance between the Sun and Pluto. Although black holes are powerful, they will eventually evaporate through Hawking radiation. To comprehend this process, we must look at empty space. Virtual particles appear and disappear in empty space, creating and destroying each other. At the edge of a black hole, one virtual particle will be sucked in, while the other will escape and become a real particle. Thus, the black hole loses energy. The process begins slowly and accelerates as the black hole shrinks. When it reaches the mass of a huge asteroid, it radiates at ambient temperature. With a mountain's mass, it radiates approximately the same heat as the Sun. In its final moments, the black hole emits the energy of billions of nuclear bombs in a massive explosion. The process is extremely slow, with the largest black holes taking up to a Google year to evaporate. Because of its length, no one will be there to witness the last black hole radiating away.